Hi everyone. I'm going to discuss how to sketch the graph of tangent and cotangent functions. Now, unlike in the previous four functions whose graphs that we have studied previously, so the tangent function has period equal to pi. So meaning the graph or the behavior of the graph will be repeated after pi. Unlike with the other four, the period is usually equal to 2 pi. Now, since tangent is equal to sine x all over cosine x, tangent values would be equal to 0 when sine values or the numerator are 0 and undefined when cosine values are 0. Now, as the x coordinates go from negative infinity to, or rather goes to negative pi over 2 to pi over 2, the tangent values go from negative infinity to positive infinity and increases throughout the interval. Now, those same value are repeated as x goes from pi over 2 to 3 pi over 2, which is actually another interval. And then 3 pi to 5 pi over 2, which will be another interval. So, as what I've mentioned, as we finish one period now and begin with another period or another interval, the graph will just be repeated and so on. So the graph of y equals tangent x from negative pi to 3 pi over 2. So that would mean um, more than one period. So as you can see here, although I'm going to discuss the step-by-step procedure how we sketch the graph of tangent and cotangent function, just to give you an overview, that will be the graph of y equals tangent x. So this is from negative pi until 3 pi over 2. So it keeps on repeating only after one period. So how do we sketch the graph of tangent and cotangent function? So to graph y equals a tangent bx or y equals cotangent bx with b greater than 0, we can determine the period by initially starting with pi. Now, as b increases, now the period gets narrower or decreases. So the period would become pi over b. So meaning we're going to divide the period pi by whatsoever the value of b. Now, after identifying the period, it's necessary that we should know and locate adjacent vertical asymptotes. Now, these vertical asymptotes class are the values of y equal to undefined values, and these are the restrictions of the domain. So, same with secant and cosecant functions, tangent and cotangent functions have also vertical asymptotes. Now, in identifying the vertical asymptotes, because we need that for us to initially sketch the graph over one period interval, we need to locate the vertical asymptotes. And the vertical asymptotes for y equals a tangent bx, we have bx equals negative pi over 2. Then the other vertical asymptote equal to bx equals pi over 2. Now, if you notice, from negative pi over 2 until pi over 2, so the distance there is pi, which is equivalent to the period of tangent and cotangent function. Similarly, the adjacent vertical asymptotes for y equals cotangent bx, we have bx equals 0, and then another one is bx equals pi. So from 0 pi to pi is equal to, the distance there is equal to pi, which is equal to one period. Now, as what stated in the previous slide, to add more or to expand more the graph, with adding more vertical asymptotes, we will just be adding multiple of pi or pi over b depending on the period to expand the graph. So after identifying the adjacent vertical asymptotes, we need to sketch the two new vertical asymptotes found in step 1. Now, we will divide the interval, which is actually equal to 1 period, by dividing it into 4 equal parts. So meaning what we will divide is the period. For that example, the period equals pi. So we will divide pi by 4. So pi over 4 will be added to negative pi over 2 until we reach pi over 2 cumulatively. Same with what we did as we sketched the graph of sine and cosine function. So if you remember, the period for sine and cosine function is 2 pi. And then for us to identify some values of x, we divided 1 period, which is 2 pi, by 4 equal parts. So that's why we arrive with pi over 2. In this instance, instead of dividing 2 pi, we will divide pi, which is originally the period for tangent and cotangent function, by 4. So we'll be adding pi over 4, for instance, starting with the lower limit, negative pi over 2, until we reach pi over 2. So in that sense, we are able to identify some values of x. And we're going to evaluate the function for the first quarter point, midpoint, and third quarter. Meaning we will evaluate the value for us to come up with y, and we will connect those points that we were able to identify from the previous steps approaching the vertical asymptotes. Take note that the point will just be approaching or will just approach the vertical asymptote, never that the graph will overlap the vertical asymptote, since the vertical asymptotes would serve as the restriction. So the vertical asymptotes are actually not the values of, or not a possible value for x for the domain with respect to y equals tangent x and y equals cotangent x. Okay, so let's work on some examples here. So we're going to sketch the graph of y equals tangent 2x. Now, the period there, as what I have explained, would be, oh wait, so the period now is equal to pi for tangent and cotangent function, pi over b, since b is equal to 2, so the period becomes pi over 2. Okay, so in comparison to y equals tangent x with y equals tangent 2x, the graph becomes narrower. Okay, and then we're going to work on its adjacent vertical asymptotes. So we have bx is equal to quantity negative pi over 2, or this must be 2x now. So we'll divide both sides here by 2, and x equals negative pi over 4. With the other vertical asymptote, we have 2x is equal to pi over 2. Okay, we have pi over 2 here. So dividing both sides by 2, we got the other vertical asymptote equal to pi over 4. So one period interval for y equals tangent 2x is from negative pi over 4 to pi over 4. Take note, class, that the length of this interval is equivalent to the period, which is equal to pi over 2. Okay? Now, from negative pi over 4 to pi over 4, we will come up with x coordinates or values of x. So, for example, we have x here and then negative pi over 4 until pi over 4. And then we will locate the middle points here. And how do we do that? So previously with sine and cosine, we divide one period by 4 because we want to divide this by 4 equal parts. So the period here is pi over 2. So we will divide this pi over 2 by 4. So we got pi over 8. Meaning we will be adding pi over 8 cumulatively from negative pi over 4 until we reach pi over 4. And negative pi over 4 plus pi over 8 gives us negative pi over 8. Negative pi over 8 plus pi over 8 gives us 0. And 0 plus pi over 8 is pi over 8. And pi over 8 plus pi over 8 is pi over 4. And then we will evaluate the y values. So we have these x values. So before we come up with the y values, we have to note that we need to come up with 2x. And 2x is multiplying each value of x here by 2. So we will go back with the original interval. So we have 2 times negative pi over 4 gives us negative pi over 2. 2 times negative pi over 8 gives us negative pi over 4. 2 times 0 gives us 0. Then 2 times pi over 8 gives us pi over 4. And 2 times pi over 4 gives us pi over 2. And then we will evaluate tangent 2x here. Now, you can recall the unit circle for us to easily evaluate the tangent values from the second row. And we know that negative pi over 2 is like a quadrantal value. And somehow this is coterminal with pi over 2 here. And we know that the points that we got from unit circle here is 0, 1. So its tangent value is undefined because we come up with the denominator 0 here. So we know that tangent equals y over x. Or I mentioned about sine x over cosine x. Since cosine or the denominator is 0, then we come up with undefined value. And I was able to mention that the boundaries here are actually the asymptotes. And the y coordinates must be undefined since these asymptotes are the restriction to domain. So as we evaluate the restriction, we will come up with undefined value. So same goes here. So this must be undefined. That's why we represent this by the vertical broken line, which is we call as vertical asymptote. Now, in relation to unit circle, we have this pi over 4 here. And for example, this is the unit circle. And if we recall, the coordinates of pi over 4 here is square root of 2 over square root of 2. Then we want to evaluate tangent negative pi over 4 this time. So that involves a negative value. So if it's tangent negative 4, so this will rotate counterclockwise. So this is equivalent to pi over 4 with coordinates equal to square root of 2 over 2 all over negative square root of 2 over 2. Or you can verify using your calculator and then make sure that your calculator is in region mode, that you evaluate tangent negative pi over 4, and then this will result to negative 1. Okay? Because we divide a negative value by a positive value. Now, for 0, so the tangent of 0, so this can be associated with 0 here. And then this is composed of 1, 0. And this is tangent. So y over x. So this is 0 over 1. So tangent 0, also using your calculator, tangent 0 in radian mode will give you a value equal to 0. And then tangent pi over 4. So we have pi over 4 here. So using the unit circle, so x and y are equal. So when you divide two same values, this will result to positive 1. Now, these points, this will be your x coordinate and this will be your y coordinate. So we will plot these points over one period interval, but let me show you the vertical asymptotes first. So these are the vertical asymptotes, particularly for negative pi over 4. So this is negative pi over 4 until pi over 4. Because this is negative pi over 2. And then from negative pi over 2 to 0, in between is negative pi over 4. So this must be the one period interval that we are trying to work out here with this x coordinates. So we will be plotting these points like we know that this is undefined, and then negative pi over 8 from negative, this is negative pi over 4 to 0. So this is in between, but we have to consider negative 1. So this is negative 1. Okay. And then we have 0 here, 0, 0. And then we have pi over 8. So that's in between 0 and pi over 4. But it's 1. Okay. So we will connect the points, these points. And then the behavior of the graph will increase going to this direction and will move down going to this direction. So as we connect the 3 points into, or the middle points into a sinusoidal curve, we will get this graph. So take note that the graph will never touch the vertical asymptote. So we can repeat the graph, like for instance here. So we want to repeat the graph on both sides of this interval. So they will have the same y coordinate. It's just that what we will do is to divide each interval into four equal parts. So 1, 2, 3, 4. And this will have the same y coordinate with this one. So somewhere here. And then this will have the point with 1. So somewhere here. Okay. So this graph will have the same y coordinate as it repeats from one interval to another interval. They will just differ with the x coordinate. And the x coordinates are actually, each interval is divided into four equal parts. Okay. So next we have negative 3 tangent 1 half x. So the period is equal to pi over b. B here is 1 half. So this is pi over 1 half. So this is pi over 1 half. So p here is 2 pi. Okay? So p is 2 pi. So let us identify the vertical asymptotes over one period interval. So again, bx for tangent is equal to negative pi over 2. So this is 1 half x equals negative pi over 2. So if we divide both sides by 1 half, so x is equal to negative pi. Okay? And then the other vertical asymptote, we have bx equals pi over 2. So this is 1 half 1 half x, sorry, equals pi over 2. So we will divide again both sides by 1 half. So x is now equal to pi. So one period interval for this graph is from negative pi to pi. Well, from negative pi to pi, so the distance there is equal to 2 pi, which is the period for that function, negative 3 tangent 1 half x. Originally, the period is equal to pi, but since b is 1 half, so since b is less than 1, so the graph becomes wider instead. Okay? So let us sketch the vertical asymptotes. Okay. So this is from negative pi to pi. And then the period is 2 pi. So for us to identify some values of x, like this is negative pi and this is pi. Okay. The three middle values can be identified as we divide the period by 4. And this is pi over 2. So we will be adding pi over 2 cumulatively from negative pi until pi. So as we add pi over 2, this becomes negative pi over 2. Negative pi over 2 plus pi over 2 is 0. And then 0 plus pi over 2 is pi over 2. And then let's work on 1 half x here. So 1 half x, so 1 half of negative pi is negative pi over 2, while 1 half of negative pi over 2 is negative pi over 4. So 1 half of 0 is 0. And then 1 half of pi over 2 is pi over 4. And then 1 half of pi is pi over 2. So we go back with the original period of tangent, which is pi. And this is from negative pi over 2 to pi over 2. But our x coordinates will be the values of x here. Okay, so we'll consider these values as the x coordinates. Okay, and then we will evaluate these x coordinates and come up with the y coordinates for us to sketch, to plot the points and connect the points into a sinusoidal curve for us to come up with the graph of y equals negative 3 tangent 1 half x. So we are now going to evaluate tangent 1 half x. And we'll get the tangent value of this. So we know that this is undefined. This is undefined. Okay, so tangent negative pi over 4. Same with our illustration in the previous slide. So this is pi over 4. This must be coterminal with pi over 4 here. So if the coordinates here is square root of 2 over 2, square root of 2 over 2 for both x and y. So since this is now in the fourth quadrant, we'll come up with so, 'di ba, tangent value on quadrant 4 will be negative because the y coordinate is negative. So, this is like y divided by x for tangent. Since the two are the same but exactly the additive inverse of each other, the value here will be negative 1. And then tangent 0. So, we represent this by 0 and the coordinates is 1, 0 in reference to unit circle. So this is y over x. So this is 0 over 1. So tangent 0 is 0. Well, tangent pi over 4 is 1. And then we will add that by negative 3, whatever the result in row 3. So negative 3 tangent 1 half x is, so this will remain undefined. And negative 1 minus 3 would be negative 4. And then we have negative 3 here. We have negative 2, and then this will remain undefined. So we will be plotting these points, x and y. So the last row will be the y coordinates. Like we have negative pi over 2, negative 4. So somewhere here maybe, somewhere here. Okay, because this is negative 3. So let's assume that, well, somewhere here. Okay. And then this is let's consider that this is negative 4. Okay. And then for 0, it's negative 3 here. 0, negative 3. And then for 1, negative 2. No, no, no. For pi over 2, negative 2 here. And then we have pi over 2. I'm sorry, pi undefined here. So if we're going to connect these points, we'll come up with, but we have to note that this negative 3 is a factor. So instead of adding, we will multiply. So we have here. So this is not negative 4. Instead, this will be positive 3. So negative 1 times negative 3 is positive 3, while 0 times negative 3 is 0. And then 1 times negative 3 gives us negative 3. Okay? So this negative 3 is a factor, and this is your A. So we have negative 3 times the values on the third row. So we have, this will remain undefined. This is negative 1 times negative 3. This gives us 3. And then 0 times negative 3 gives us 0. 1 times negative 3 gives us negative 3. And then this remains undefined. So the point will now then be from um, pi undefined, and then negative pi over 2 to 3. So the point will be here. Okay. And then 0, 0, 0 here. And then we have 1, negative 3. I mean pi over 2, negative 3 instead of negative 2. So negative 3. And then undefined. So we have here pi, negative pi over 2, 3. And then 0. And then negative 3 here. So we will connect this point into a sinusoidal curve. So we'll be able to have this graph. Okay. So we will repeat the process, like we will just differ with the x coordinates, but we still come up with the same y values. Now if we're going to compare the graph from the first example, y equals tangent 2x. Now usually the graph of tangent x is increasing from left to right. So with the first example, so it's increasing. But this becomes decreasing from left to right, decreasing and then decreasing, because we come up with a negative tangent. So the graph will be flipped. Okay? So the direction was changed. So this became a decreasing function now. So this the graph decreases from left to the right interval. So this time we'll work with cotangent. So the graph, usually the behavior of the graph of a cotangent function is decreasing from left to right. So, but we've got the same period. So the period for cotangent function is pi, and we will divide that whatsoever the value of b, which is 2 in this example. And the adjacent vertical asymptotes is equal to bx equals 0. And then we have bx equals pi. Now, our bx here is 2x equals 0. So we divide both sides by 2. So x is 0. X equals 0 as one vertical asymptote. The other one is 2x equals pi. So we divide both sides by 2. The other vertical asymptote is x equals pi over 2. So what interval for this cotangent function? One period interval is from 0 to pi over 2. Now, the distance from 0 to pi over 2 is pi over 2, which is the period for this function. Okay? So, this is the vertical asymptotes. So, we have from 0 to pi over 2, pi over 2 to pi to 3 pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi, and then same goes with the other side of 0. So the next thing that we're going to do is to come up with the x values. So we begin with x here. So we'll begin with 0 and we'll end with pi over 2. And then this period pi over 2 will be divided by 4. So we know what value are we going to add from the lower interval or lower limit of the interval until we reach the upper limit, and we will be able to provide some middle x values here to sketch the graph of this function. So basically, we will divide the period pi over 2 by 4. So we have to add pi over 8 cumulatively from 0 until we reach pi over 2. So this is 0 plus pi over 8. We have pi over 8. Pi over 8 plus pi over 8. We have pi over 4. And pi over 4 plus pi over 8, we have 3 pi over 8. And 3 pi over 8 plus pi over 8 gives us pi over 2. So the next thing that we will do is to evaluate 2x. So we will multiply each value of x here by 2. So this remains 0. And then this is pi over 4. Pi over 4 times 2. So this is pi over 2. And then 3 pi over 8 times 2. So this gives us 3 pi over 4. And pi over 2 times 2 gives us pi. And then we'll evaluate cotangent 2x. Now, it's hard sometimes to evaluate cotangent functions, especially if we're going to use calculator, since we will be doing or adding additional process. And as we work on adding process, we will be prone to error. So we can consider the unit circle as what we have made use in our previous example, because this involves only evaluating 0, pi over 4, pi over 2, and everything here is positive, so it's easy for us to evaluate. So in relation to unit circle again, this is 0 with coordinates 1, 0. And we know that cotangent is x over y. So that's why this gives us undefined value, because these are the restriction for the domain. So understandably, we'll come up with undefined value. Now for pi over 4, this is our pi over 4. And the coordinates here again are square root of 2 over 2 and square root of 2 over 2, since this is on the first quadrant. So everything is positive. And cotangent is x over y again. So this gives us 1. And then pi over 2 is a quadrantal value located here. And the point that we assign, since this is a unit circle, is 0, 1. And cotangent means x over y. So this is 0 over 1. So cotangent pi over 2 is 0. And then for 3 pi over 4, cotangent 3 pi over 4 would be, so we have 3 pi over 4 is somehow located here. So this is 3 pi over 4 with coordinates equal to negative, since this is on the second quadrant. So this is negative 2, square root of 2 over 2, and then square root of 2 over 2. So this gives us equal to negative 1 for tangent 3 pi over 4. Or rather, cotangent 3 pi over 4 gives us negative 1. And then this is expected to be undefined, cotangent pi. Now, let's work on the last part, wherein we're going to evaluate 1 half whatever the value of cotangent 2x. So everything will be multiplied by 1 half. So this remains undefined. So this is 1 half. This is 0, negative 1 half, and this is undefined. Okay. So plotting the points, like from 0 to pi over 2 here. So if this is from 0 to pi over 2, this is pi over 4, this is pi over 8, and this is 3 pi over 4. For pi over 8, this is 1 half. And then for pi over 4, we have 0. And then 3 pi over 8, we have negative 1 half. Rather, for pi over 8, we have 1 half. So it has to be here instead of here. And then pi over 4, 0. And then we have 3 pi over 4, negative 1 half. So it must be here. So plotting the points, connecting the points sinusoidal into a sinusoidal curve will come up with this graph. Okay. So take note that the graph becomes narrower in comparison to the graph of cotangent x, since b is greater than 0. So this is how to sketch the graph of tangent and cotangent function. Normally, the graph of tangent function is increasing from left to right. But if it's like a negative tangent x, like we have the value of the amplitude is negative. So the graph will be flipped, like the behavior will be increasing from left to right. Now, on the other hand, the graph of cotangent function is decreasing from left to right. If we come up with a negative amplitude, or should I say negative cotangent, then that's the time that the graph will be flipped and the graph will be increasing. So that's it for now.